Hi, everyone, and welcome to today's webinar organized by JetBrains. I'm Paul Everett, PyCharm Developer Advocate, and I'll be your host. The topic for today's webinar is MongoDB Quickstart with Python and PyCharm. Today, we're very fortunate to have a special guest. Michael Kennedy is well known in the world of Python as an author, speaker, instructor, great guy. Probably best known for his Talk Python to Me podcast and its companion Talk Python training. Michael, is it safe to say that the Python Bytes podcast you do with Brian has gotten pretty popular too?
Yeah, it's growing with new users every day. It's amazing. So it's great to see people appreciating that other format as well.
Good format for busy people, right?
That's right.
Michael's done over 100 week-long Python training courses, bringing the good word of Python to the huddled masses worldwide. In the past months, Michael has shipped 2 new courses, Mastering PyCharm. Kudos to you for that.
Yeah,
and
thanks.
also the topic of this webinar, MongoDB Quickstart with Python and PyCharm. Michael, how's the response been on these?
People have really loved these courses. The response has actually been better than expected. It's probably close to 20,000 people have taken the course that we're about to sort of cover similar stuff. So yeah, it's pretty amazing.
Wow, 20,000 people. Did you expect that when you made it? Where you're like, oh, I better get this
not
right.
that many. Not that many. I thought more because it is free, right? But still, it's a lot.
Yeah.
All right, well, let's get going. Okay, so welcome to MongoDB and Python with PyCharm. We're going to go through and basically create a small application, and we're going to model something that, as people familiar with Python, you should all actually be really familiar with. So I think it'll resonate a lot with everyone. Paul did mention I have a MongoDB Quickstart course. That is not the same content that I'm doing here. So if you happen to have taken that course, you're going to get something different this time. So that's good. It's additive, right? Some of the concepts, of course, are the same, but the demo we're going to build, I made this yesterday, so I wanted something fresh for you all. So it's fresh off the presses. So what are we going to cover? We're going to talk about the tooling we're going to use. We're going to talk about MongoDB really briefly, like what is it? Why do you care about it? Why is it a decent choice for a database? And then we're going to spend most of our time building something fun and then looking back on some of the concepts here. And then if we have time, I'll take questions. We already discussed that a little bit, so feel free to jump in right away. Another question, maybe that pairs with, is this being recorded, is can I get the code to take with me? Yes. Here's a URL, github.com/MikeCKennedy/JetBrains webcast build with MongoDB. I'll be sure to give that to Paul to share with everyone as well and whatnot. So I'm going to be working in this fresh GitHub repo, and then everything you see me do, I'll commit, and it'll be public. You can grab it pretty much right after we're done with this session. All right, so what we're going to use MongoDB. That's pretty obvious. You can't have MongoDB without that. We're actually going to use this library called Mongo Engine, which is an ODM, object document mapper, which is like an ORM for a document database. There's a bunch of these for MongoDB. This one, I believe, has the right feature set, right API to really make it super useful. We're going to be using this thing called Robo3T, also known as RoboMongo, a nice visual way to interact with our database, and of course, PyCharm. So I just want to set the stage really quickly for everyone out there who maybe doesn't have a lot of experience with MongoDB. I'm going to assume everyone has some basic experience with Python at least. Maybe you don't have tons of it, but some. However, for Mongo, well, let's just talk really briefly. Before I show this thing that's on the screen here, I just want to set the stage and say that it's important that the databases you work with are popular. It's not like high school. It's not a popularity contest, but by virtue of these databases being popular, that means they are put through the ringer under some extreme circumstances, right? Like they've really been used in workloads that are probably massively heavier than what you'll ever add for it, or ever do for it. So if it can survive that, it can survive what you're going to give it. Also, that means there's a lot of libraries to work with it. So unlike additional ODMs. So if you look at the various document databases that are around, you'll find that one of them is unlike the others. The blue one, MongoDB, is clearly more used, more popular, and growing compared to Cassandra, Couch, Raven, and so on. Also, if you look at the Stack Overflow survey, developer survey 2017, it was the most wanted database by almost a factor of 2 over Postgres, which gets a lot of love, and then it tails off pretty quick from there. So this is a sort of a good place to be in terms of data. Let's talk about how document databases work. MongoDB is a document database, but so is CosmoDB, RavenDB, some of the other ones, CouchDB. They're all sort of this general style of working. And the idea is you create embedded documents. Sometimes it's actually JSON. In MongoDB, it's a binary representation, but it's effectively the same as if it were JSON, but you can't read binary, so I didn't put that on the screen. So what you get is you can model stuff like you would in a traditional database. So you've got your columns, like these are your columns, right? ID, title, course ID, and so on. But then you have something funky down here, like what is this nested thing, right? So you've got this thing called lectures, but the lectures is actually an array of sub-objects which have ID, title, video URL, and so on. And so this here, this is actually an embedded document. And so when you see things like this, you can think of this almost as like a pre-computed join. So if we're going to work, like this is a chapter from one of my courses in the database. If we're going to almost every time we have a chapter, we want the lecture, we have one lecture, we want the other lectures in its chapter, like modeling like this sort of pre-computes the join so that you can get to it much faster. And actually the modeling is simple, as we'll see. So this, like I said, is this pre-computed join. Now the big question, the $64,000 question is, if you do this, can you still ask interesting questions about the stuff that's embedded? Like, could I go to the database and say, give me the lecture 10106, right? Can you query deeply into these things? And luckily, the answer is yes. You can do this. You can do this super fast. You can do this with an index. And we're going to see this as we go. All right, so what are we going to build? I told you you'll be familiar with it. We're going to build PyPI for our demo today. Now, just to set the stage, PyPI is a web application written in Pyramid, at least the modern, newish version of it. And it's got probably a relational backend. I don't actually remember what they're doing. So it's not to say that they're doing this with MongoDB and whatnot, but what we're going to do is basically focus on the data access layer that would be a theoretical PyPI implemented in MongoDB and Python. Then you would, of course, layer that into, say, a web application. You could use Pyramid like they are, or you could use something else. Okay, so this is what we're going to build. Now, let's look, before I show you this relational model here, let's look, just pull up the website and poke around for a moment. I believe that changed my resolution. I don't appreciate that. Let me put this back. Hopefully that is going to be okay. Okay.
While you're fixing that, is it okay if I pop a couple things to you?
Please do, yes.
All right. First, someone mentioned, and it's true, the GitHub repo currently doesn't have anything in it but the README. Is there some stuff you're going to push later?
Yes, absolutely. I'm going to write it. It doesn't exist yet, so I got to type it first.
Oh, okay, great.
It's going to as soon as I type. All right, so we're gonna,
while you're figuring this out, I'll answer the next one. There's a question: why does PyCharm not have support for MongoDB? It's a good question. It's a very frequently asked question. PyCharm Professional includes DataGrip, our IDE for SQL. And that's why we don't include support for MongoDB, because DataGrip only supports SQL-oriented databases available under JDBC. So there's a very popular ticket over in the DataGrip issue tracker. You can go and vote for it. Now, one last question. This one can go to Michael. How does MongoDB handle financial data such as sales data compared to a traditional database? You talk about that in your 2-hour course, but here you can give a little plug.
Sure, I think it handles it entirely fine. There's only one area that I know of that is really critically different than you might think of as a traditional database. And that has to do around transactions. Now, MongoDB doesn't have transactions. However, that is not as bad as it sounds, because updates to individual documents are transactional. So what you can see is that if I want to change, say, like I had that example of that course with the chapter and the lecture, if I want to change a bunch of lectures, I could do that transactionally. But I couldn't change lectures across courses that are unrelated to each other transactionally. So if you were doing like banking stuff where I have to say debit this account, credit that account, and I have to do that in a transaction, that probably is not best done there, but certainly e-commerce sites are easily built on them. An example, Under Armour had their e-commerce site built on MongoDB, and they were doing $2 billion a year through that site. So that seems like it's fine. Like my e-commerce site runs through MongoDB, for example. It doesn't yet do $2 billion, but we'll see about that. Anyway,
that's a big number.
That's kind of what I was saying before about the popularity thing, right? Like you're like, oh, well, I've got a pretty busy e-commerce site. Like, well, Under Armour did 2 billion. Like, do you do 2 billion? No, we only do 1 million. Okay, well, see, right? Like that's sort of the why you care about these things being popular. Right. So anyway, I think the one thing you got to think about is the cross-record transactions, but it's not as bad because the records here are much richer, and often you'll find you really want to update different parts of the same record.
All right, that's our questions.
That's response. Okay, great. So Great. So let's look at PyPI, right? PyPI is when you pip install a thing in in Python. This is where it comes from, and then this place up here is where you find stuff. So let's go to find Mongo Engine. This is, for example, actually let's look at requests. I remember there's not that much information filled out there. So if we look at requests over here, you'll see that it has a name, it has an install thing, it has a latest version. You can come down here, it has like a description and other stuff. You'll see a bunch of details about it. Sometimes, not on this one, I'll pull up another. It'll have like the health, the code coverage, continuous integration, whether that's working, and so on. Here you'll see we have a release history. These are all the different versions. And if you click on each version, you get the same details, but for that version. If you go back here, back to this main, you can see it's got like the download files, it's got the license, who maintains it. There's 3 maintainers of it. It's license. It's here. Notice this is really interesting. Programming languages. Some of them have topics. Like, let me see if I can pull up the Mongo engine 1 and get some slightly different information for you. Yeah, so here you can see topics or database, software development, and so on. And up at the top, it has the build is passing, the code coverage is this, and the health is that. And this is a per release history thing, okay? There are users, the users can be maintainers, users can contribute packages, and so on. So what we're gonna do is we're gonna model that in MongoDB. I'm gonna build out a bunch of that sort of thinking about it, getting started in Mongo with just from scratch, live, and then I'm going to drop in a little bit of finished code, not because we couldn't build the app in time, but because we can't. I'm going to work with this huge database with millions of entries that will take like 10 minutes to generate from whatever we build. So we're going to have to do a quick little swap there, like partway through, to actually to see it in real use, right? Not like, oh, I have 2 records in the database and look, it works fast, yay! Like, of course it does. It has 2 records, but with millions of records. Okay. So that's great. We're going to build this thing out. Now let's look at the model here. And I don't want the screen to be messed with anymore by PowerPoint. So I'm just going to leave it like this for now. So this is what I think a reasonable relational model works. I didn't actually look at what they're doing. I didn't actually go and take their real database. This is just me looking from the outside what I think you need to generate those pages. So notice right here we have our packages, and the packages is super intense with lots of relationships to it. It has the topics, right? One to many. There's multiple topics applied to a package like database and queries and ODM and whatever. There's different OSs this will run on, the various package. There are different programming languages like Python, Python 3, Python 2, and so on. We saw that listed on both requests and others. This is the health. This is like the continuous integration is running. This is the code coverage, and so on. There's the maintainers, which is actually just a normalization table between packages and users to say, okay, these set of users are maintainers of these sets of packages. And then we have the dependencies that the package depends upon, right? If I'm going to install this, it also has to have those other pieces. We have our release history, and it turns out that even though packages looks like it's super intense, release history is the place where most of the details go. And then what you don't see on that screen but exists is a download record. Every time somebody pip installs something or downloads something off of PyPI, it gets recorded, the version of Python, the app they were running, was it pip, was it something else? All that stuff is recorded, so they have a bunch of analytics. So this is the relational model, and I think this is probably, this is a simple view of what would be a real application. Would be even more intense, okay? Like a real app would have many more tables. It's just trying to render that one page. Now, how would this look if we model this, or how is this going to look when we model this in MongoDB? One of the things that I think is often overlooked about document databases, people hear NoSQL, they hear document databases, and they think performance is what matters. I don't. That's nice that it may be faster or fast, but what I think really most people have, not everyone has a performance problem in the extreme, but everybody has a complexity problem. Like my program is hard to add new features to, or it's getting complex or whatever. And so you'll see that working with the document databases actually simplifies your data model dramatically. And that means it's easier to add features, it's easier to evolve. There's very rarely migrations or anything like that. It's easier to bring new people on and so on. So take this model that you have here, and if we look at it, this is the document database model, okay? We have packages, they have a release history. You can download a release. Users are related to packages indirectly, okay? So I'll just flip back real quick for you. Relational style of modeling, document database style modeling. Which one do you think is easier, right? Which one is easier to understand as a new user, which new developer? Which one do you think is easier to evolve over time and so on? Okay, so this is nice. We're not going to have a lot of models, but it does add the complexity in a different place because what packages and release history are is richer. All that information is still there. It's just embedded in this document. So if we look here, you can see our packages actually is super wimpy. We have an ID, we have a name, we have maintainers, but the release history, because that description may change, the dependencies may change, the operating system it runs on may change as you release new versions. All that detail actually goes here. So we have sort of the columnar stuff here, ID, package, version, and so on, but we have topics. And notice we can store these as strings, operating system as well, programming languages as well. The health, we can embed a health object into this, right? So we have a nested object that has properties like CI and coverage and so on. And we can have dependencies which actually have an array of rich subobjects. So that's all really interesting. My legend didn't quite come out quite right, but then the rest of the stuff is pretty much like flat things. Okay, so it's time to go build this thing. Let me get this PowerPoint out of the way because the real good stuff is actually writing code. So that's what I call my folder. It's code. And we're
I will go ahead and tee up a couple of questions, if that's all right.
Yeah, tee them up.
Two good questions. First one, Thomas says he recently listened to the Talk Python episode with the Quart author and got really excited and asked, how well does MongoDB play with async I/O in Python 3.5 plus?
Oh, you're stabbing me with a knife. No, I as far as I know, I don't think it does. To be fair, like neither does SQL Alchemy, right? Like it's really unfortunate that the ORM folks are not embracing some form of async. The only one that I know of is I guess there's the extensions, the async extension for Peewee ORM, if you've ever heard of that. And there's also Tornado SQL Alchemy, but it doesn't use async and await. It uses the coroutine yield style of programming. Also not the best. So there's just not a great option for it. Databases are the perfect place. Well, it's a perfect place for async, but you also see that the database is super fast for what we're going to build. Like the response time is so fast that it may it may be okay, but it would be nice if it supported it, but I don't have a great answer for that, sorry.
All right, next question from Yuri. What kind of data would you not recommend to be stored in Mongo?
What kind of data would I not recommend? I think that's a good question.
From your tutorial, from your video, anything bigger than 16 megabytes.
Well, that has more to do with how you model the data, not necessarily whether it goes in there. I mean, if you're going to store a binary blob, there's a mechanism for storing that outside of that restriction. But what would you not put? I think it's not so much that there's data itself that doesn't fit well in there. It's your usage pattern of the data. Like, do you have to do heavily transactional stuff? Right. That is like really dispersed. Like, I want to transactionally add 2 users and update a package and modify the download history. Like, that basically cannot be done. You know what I mean?
Right.
So,
last one. Yeah. Would you consider a different database for relational data and use MongoDB for only part of your data? Again, that's something you have in the Quickstart. You have this diagram that talks about a multi-database approach.
Sure. I think there's 2 ways to look at this, 2 areas to focus on. One is, can I have MongoDB just be my database, or do I need something different? And in terms of operational stuff, I think actually you can totally have MongoDB be your only database. A lot of people will try to like they'll sort of like step gently into the cold water type of thing, and they'll say, well, we're going to do a little bit in one database. We'll keep the other in the safe one. And I don't know that that makes a lot of sense. But where I do see people saying, look, we need to have this other database, is around reporting. So if you want to do, like, suppose you have people who know the SQL language and they write reports and they use like the Crystals report plugin to like map to create these charts, and it has to talk to a relational thing. You could have an operational document database and then a cron job that like will replicate that over into a pre-computed, better for reporting warehouse database that is relational. That would make a lot of sense, I think.
Right. Okay, that's it. Let's get to the code.
Yeah, so let's get to the code. So we're going to open this in PyCharm, and on Mac OS, you can just drag and drop it. That's really nice. Now, there's very little code here. I'm going to go to source. I'm going to say set this as sources root here. And I want to add a virtual environment. So I can actually go over here to the properties and go to the project. And this is cool. This thing you added here, Paul, say add a new local environment, and it'll automatically suggest to create this new VE&V there right at the top. So that's great. We'll do that. And it's thinking about it. And I'll go ahead and hit that set of tools with an update. Give it a second. It said there's an error, but there's not actually an error. Don't believe that. So we come down here. We can ask which Python or which pip. And it's the one on my desktop, which is great. So we're going to have to install a few things. We're going to install Mongo Engine, which is going to drag along the base package called PyMongo that we're going to need. A few others as well, like 6. We'll go ahead and get that installed straight away. Now, I have this program here that we're going to run. And what it's going to do is it's going to, set up the MongoDB connection, and it'll let us go around and ask a question like, I'd like to get information about a package, effectively display that page I showed you, or show me an analytics report about downloads, or just exit. Now, this is not written, as you can see here. So our goal is to go write the code that defines the models. I think that's actually the most interesting part. And then we'll write a little bit of query syntax, not here, because that would be wrong. We're going to put it into its own layer in our application and write it there. So let's begin. Whenever I do like a screen sharing, the right click goes a little funky. So we're going to create a directory, and I'll just call this data. And into data, where do you want to start? Let's start actually with, I guess we'll define the packages first. So let's say packages. And because this is a Git repository, you can see down here, Git master. PyCharm says we're going to add this to your Git repo. Yes, thanks. It doesn't commit it, just does a stage basically. So down here, what we need to do to define one of these models that we were talking about is we're going to define a class, and we'll call it something like package. It's going to be a singular thing, and it's going to derive from Mongo Engine. Now, PyCharm says, probably not. You probably need an import statement. But of course, if I Mongo Engine, if I do this right, it'll say, I think it's already installed. Why does it want to install it? Yeah. Anyway, it'll put it up here for us. So what we want to do is derive from document. So everything that's going to be stored as a top-level item in MongoDB derives from document. There's also embedded document, like here, that we can say for health record or release, a dependency that we talked about previously, things like that. So we're going to do a document though. And then if you've done any of the ORMs, this is really similar. It's like Django, it's like SQL Alchemy. What we're going to do is we're going to say, we're going to have like a name of a package, and this is going to be a MongoEngine.string field. Notice in PyCharm, you can say capital SF, sort of cap word it, cap letter it, and it'll pull that out. That's really sweet. And we could even say this is required as true, which is pretty sweet, okay? So we also want to have, I think, the maintainers. Now, this is where it gets a little bit different from a relational database, because this is actually going to be a list. It's going to be a one-to-many relationship, but it's just going to live inside this document. And basically what that means is every time we get a package, we are saying we would always like to take the details, at least the info, a little bit of info about the maintainers with us. But these map over to the users table. So we're going to say this is going to be a list field, and what's going to be in there is a MongoEngine.object ID field. These are the IDs of, basically the IDs of the user. So we're going to have a list containing the IDs of the users who are the maintainers. Now I think that might more or less do it for us. Now there is a quick little thing here that we want to do, and I'm going to borrow this from my example because I don't want to get it wrong. Let me just grab, there's a little bit of metadata that we got to put at the end here. And it's a sort of meta piece. I couldn't remember if it's under meta or just meta. And we need a little bit of information to tell how this class maps to the database. So even though it's called capital P package, what you would think of as a table name or just the collection name is what they call it in MongoDB, is going to be packages, lowercase, plural. Excuse me. And then, of course, we want to have indexes. So we're going to have a name here, and we would like to be able to say, find me the package by the name. And we want to do that in like a millisecond across, many thousands, millions of these, not super slow table scan style. And interestingly, we can also put an index on all of those, even the items within this list, by just saying that. Now, there's two other things that we could put here. Whenever I have a database, I basically find I almost always want to know, when was this record created, right? That's something you want to know all the time. So I'm going to come over here and say it's going to Mongo Engine date time field like this. And we'll set the default to date time. And we got to import that. So use this code intention to put that at the top. Thank you, PyCharm. Date time. Now, it's super important you do not put the parentheses there, because that will just set the default time of every record created when the program started. You want the function, not the value. So that will let us record that. And then we'll come back to this total downloads thing. I'm going to comment that out for a minute. So we can also say, if you don't order it, how do you want the default ordering of these to be? Is we could say give them alphabetical. We could write name. We could say I want them created. I want the newest one first by default, something like this. So you can sort of put this ordering thing on here. All right, so this is pretty simple. Now let's go and actually add the more interesting pieces. And just look at the time. I'm kind of thinking I'm going to grab those from the other place and just throw them in here, because this is interesting, but also I want to kind of cover all the aspects. So here's a few other pieces we can look at. Basically the same thing. So here's a download history. Like this is this user, this person at this IP address has downloaded this version of that package. And so notice we've got It's created, told you about that. And then it's got this relationship, sort of foreign key relationship to package ID and the release in that package. Now, you technically could just do this, right? You don't need the package ID because the release is going to know what package it's associated with. But you'll find that just a little bit of extra data in these document databases sometimes makes the queries so much faster and easier. So anyway, we're going to store both of those things, and then just information about who downloaded it. Like they were at this address, they used pip. The version of pip was 3.7.2. The Python version is like 3.6, you know, things like that. And similarly, we're going to add some indexes so we can make that fast. Let's look at the release health. This was an embedded thing. It lives in a release history, and it has the CI, the code coverage, and the health index here. Okay. The release history is the one that gets pretty interesting. So the release history is when it's created, of course, has the package ID, the version, the description, the topics. Notice again, this is an embedded list. The programming languages, this is an embedded list as well. And the dependencies, we could actually have this in an embedded list of more interesting stuff, but we're just going to make it strings. And then here we have an embedded document of health. So this maps over to that model that we talked about there. And of course, you know, it's just going to be called releases, and it has some indexes. All right. So that pretty much sums up the data that we're working with. But in order to actually work with Mongo, we're going to need to connect to it, right? It might be on a different server. It might be on a non-default port. Hopefully it has a username and password. Hopefully it has encryption, SSL, all that kind of stuff. So we're going to have this thing called Mongo setup here, and we're going to define a function called global init. You can call it whatever you want. And what this is going to do is you're going to call this once, hence the global. Call it one time, and it's going to basically set up MongoDB. It's going to tell it how this is actually, you know, where does it find the database? How does it connect to it? So when you do a query, this is just going to sort of ambiently be available there. So let's go over here. We'll say Mongo engine and import that at the top. We'll say register connection. And then the first thing you want to set, is the alias. This is pretty interesting. If we go back to any of these, like this first one here, notice this alias right here. So we say DB alias is core. So we're going to need to register what core means here in a second. But we have this downloads, and maybe we don't want to store the download history in that same database, right? Like I have this example for TalkPython, right? The actual TalkPython data is like 20 megabytes, but the download data is gigs. And so I don't care that often about that frequently backing up the gigs, but I do care about backing up the 20 megabytes all the time. And so what I actually do is I'll say this is an analytics database for this app, whereas the main data would live in like the real one. But just to keep it simple, I'm going to say core. But the idea is you can have these different sort of categories of database, and that actually means different connections, potentially different servers. And then I think I just say name equals DB name. And that's it. It's it for the connect to localhost simple version. It's much, much larger for here's the way I'm connecting. Here's the encryption, here's the password, here's the et cetera, right? So in production, this is a little more interesting, but here it is. So we're pretty much ready to go. Let's go up here and play with this app here. So at the top, it says we got to register the connection. So we'll say Mongo setup, and then we'll let PyCharm import that if I spelled it right. Mongo setup. No, I'll write it at the top then. From data import, Mongo setup. So what am I missing here? What do you think? All right, we'll just go with this for now. So let's say this is going to be PyPI. Now, let me do just something really quick. I'm going to say _2. So one question is, how do I define the database? Like what tooling do I use to generate it? What create scripts do I run to generate it? All that kind of stuff. And what you'll see is actually there's none of that. So let's just do this really, really quick here. I'm going to just say, let's create a package. And we're going to want to import that. Now, we're not really going to do this here in the real app, but we'll do it for now. I'll say the name is just plain. How do I put this in the database? Super hard. You call p.save. Boom, done in the database. Now, the way it works with MongoDB is there is no schema in the database. It just says, I'll take what you give me and put it in there. But what's really nice about this ODM is package is a class that has lots of structure, and so it helps keep that data integrity there. You can even have required values and min, max values, uniqueness, all sorts of stuff. Some of that's in the database, some of that's in Mongo Engine, and they go together nicely. So if I just run this, so I'm over here and just right click and say run here. It runs and it already did its thing. So let's exit out really quick. And let's go look at our other tool. So we'll connect to our local database server, much smaller than necessary. And notice there's a PyPI2 and there's a packages folder. And if you look at it, now there is the two things were created automatically, the IDE and the created. And then this is the name we set. And then maintainers has a default empty list. If we added something to it, it would have put them in there and so on. So this is really nice. So we don't have to do anything to create the database. And I say that because over here, I did create this one with all these things. And notice it even has the indexes that we put and so on. So let's look at probably the most interesting one. Like here's a standard release instance of some package. I don't know, it's whatever's linked to by that, but it has, all this is fake data, by the way, and I'll give you the script I used to generate it. But here's the version number, here's some random lorem ipsum type stuff. Here's the topics, notice how those are embedded in there. Here's the programming languages that are supported. Here's the dependencies, here's the health, like it's failing at CI, it's 81% code coverage and 88% healthy. I don't know what that means with a failing CI, but there it is. So you'll see that we even added these indexes against, say, like programming languages. So let's see all the ones, like we could come over here and write a query. I'll show you how to do this in Python in a moment. But we could come over here and say, I would like to find programming languages that have this in it. So I only want to find, I would say Iron Python. I think that's an option. I only want to find those. So you run this and boom, there they are. Notice the response time, 1 millisecond. Let's do a count and see how many of those there are. There's 79,502 that support IronPython, right? That is really sweet. So pretty cool. And if you only want some of them back, then it runs really, really quickly.
Is it okay if we go through some questions?
Yeah, let me have them.
All right, sure. First one from Nadeem. Would you suggest anything in place of transactions because MongoDB doesn't have transactions?
I would suggest what are called atomic updates or optimistic concurrency, one or the other. So all right. What I'm talking about is if I wanted to both add a programming language and update the topics and change the health and do this, you can do this with sort of what are called in-place operators. So you can push the changes. So you could say something like push Python onto programming languages and push this dependency onto that. Right. This is really good for like if you need to like increment a counter like page visits or something. You can do that atomically using these operators. That's what I would say.
All right, the next one, don't need to spend too much time on it. Currently, we're using Cassandra. What are the differences between Cassandra and Mongo? Cassandra is not feasible for frequent writes. Is Mongo okay for frequent writes?
MongoDB is perfect for frequent writes. I would say there's a couple differences, and to be totally upfront, I have not done very much with Cassandra. I think it's more of a columnar database and less of a document database. But it's also sort of eventually consistent type of thing, I believe. MongoDB is strongly consistent. There's none of this like eventual consistency weirdness of a lot of these distributed NoSQL databases. Like you write something, you ask, is it there? It's there. Right. It's sort of strong consistency in that sense, which is nice. But yes, I mean there are ways to sort of write asynchronously to it, but to make it slightly faster, but it's typically not necessarily. You can set up clusters and sharding and all that kind of stuff, which is way beyond the scope of this presentation.
Next question, and if you don't have much experience with it, I can take it. I already use JSON in PostgreSQL for my non-relational data. Can you compare it to Mongo?
I think I'm going to let you take that, Paul, but I would say also, I think there's a difference between I can have a JSON column versus the database is entirely built around the concept of modeling and documents. Right. I mean, if what you're doing is you're using Postgres and you have one column and it's just JSON, like that's probably not leveraging it correctly. I also then I'd be interested to hear from you, Paul, on this. Can you say put an index like on this in the element in the JSON column?
You can. The JSON B support that came out a few years ago is to accomplish the thing that you were just talking about. I can have an index expression. I can index the value of an expression rather than just a column. In that expression, can use the JSON operators to go fetch a child or perform a comparison or extract some text or whatever. So that's pretty clever. And it really is powerful, especially if you want to combine it with the things that you already like about a relational database, the columns and the transactions. In my opinion, at least going into PostgreSQL 11, I think the query support looks weird and is not as rich as it should be. At PGConf last year, they said in either PG10 or PG11, they will land the standard SQL standard for like JSON path or whatever it's called. So at the end of the day, you can tell you're not dealing with a document database, but you do have far richer unstructured JSON support at scale than people would associate with Postgres.
Yep. That's kind of what I thought. Thanks.
All right. Next question. With the indexes in release history that you had, there was one with health.ci, which presumably indexes on the CI field of release health. Can this be extended with further dots for more embedded fields?
Absolutely. As deep as your document goes, it can go. You just say that, dot, that, dot, that, dot, that. And that can actually be multiple items. Like, so this could have a list of objects which have properties, and you would just say programming languages dot property dot dot dot, and it'll even do like a multi-element index. Yes, you can.
Dude, we got a lot of questions. It's the benefit of being famous like you that you have a lot of people asking questions. Someone made a note that you were missing the dunder init, or was asking if the reason you had that import problem. I think it was because you were importing the module instead of a symbol in the module, and you would have had to do import something dot something instead of from something import something. What you really wanted was to go get global under init in there, and it would have all worked correctly. The robo thing, is it Mongo Compass replacement?
Mongo Compass, I think, is the tooling that MongoDB itself has. I haven't done very much with Mongo Compass. This is a super nice tool. I can't speak to the other ones. What I can tell you is really nice about this is you write in the shell language up here with autocomplete, but your results come back in a graphical form. And that is really like you get the power of the CLI, but you actually have a GUI to analyze what comes back. It's really nice.
Right. A small point back on the PG and JSON B column, that thing that you currently have highlighted would look extremely ugly in the current JSON B syntax for spelunking through JSON data.
Okay. And you can actually make it simpler. It could look like this.
Oh, yeah. I will say DataGrip does have support for JSON B, just not for Mongo.
Sure.
There's
a Mongo extension that'll give you a UI somewhat like this for PyCharm.
Have you ever
forgot what it's called.
Interesting.
Yeah, it's interesting. Yeah.
All right.
It's just not as good as Robo 3T, so I just haven't used it. No,
okay.
It's just like, it's okay, but
Michael's
it's not as
referring to an IntelliJ plugin that adds MongoDB kind of browser and query tools. Is that right?
Yep.
All right.
How many more questions we got, Paul?
Okay, sorry. We're coming in faster than we can get to them. Can we write and read null or none values?
Yes. Mongo Engine will actually not persist null values to the database, but they come back as none when you read them. And the reason is you actually store that per record. And so if this was none, you would get the same results by having it effectively missing. It does make some of the queries slightly more tricky if you don't use the ORM, but yeah, you can definitely do it, no problem.
Okay, we will speed round through the rest of these. Is there an auto generation or OR mapping, which you were just talking about?
Like, I'm not sure what you start with to generate it.
I think they're asking for Mongo Engine, an ODM instead of an ORM.
Yeah, I mean, there's Mongo Engine, right? I don't know if there's like if I had the database and I want the models, I don't really know what that is. Maybe the reverse, right? But I suppose you could write some Python code. It's just a dictionary. It's just JSON, and you could spit out classes based on that. But not that I know of.
Okay. When do you use PyMongo to access your database instead of going through a mapper?
Right. So the mapper does go through PyMongo. PyMongo lets you write this instead of work with classes, as we'll see in a moment. However, there are two things that you might be aware of that you might want to temporarily or sometimes skip Mongo Engine. One is the deserialization of many, many objects is slow in PyMongo. Sorry, in Mongo Engine. So suppose you do a query and you get back 100,000 packages. The actual query time of that may be super fast, and the response of the database super fast, but from the time it hits that layer until you have objects of that type in memory in a list in Python could be, I don't know, it could be like half a second or something unacceptable.
Okay.
Now, should you be pulling 100,000 records back in an ORM? Probably not, but sometimes you need to, and that can be a problem, so you could use it then. And there's sometimes if you just can't make the query system work in its style, then you could drop down as well.
Right. Mappers are magic. Sometimes you got to remove the magic. A follow-up on transactions, Nadim's points out that things are atomic only within a single document. If two documents are being targeted, then it's not atomic. Is that right?
Yep, absolutely. That's absolutely right.
Is it possible?
They can be as complicated as you want, but you can only update the thing you see on the screen and nothing else atomically, for example.
Is it possible to do aggregations?
Yes. There's an entire different API that is like this sort of a data analytics aggregation framework. It's a replacement for MapReduce. It's very powerful. I don't do it almost ever.
Okay, one more, and then there's still 4 more in the queue. Can Mongo store binary JSON or non-JSON objects?
The thing that it stores is binary JSON. It never stores a text. It just shows it to you as text because you don't read binary. It will also store binary objects, including very large ones, using something called gridfs, which lets you store arbitrarily large file objects, split potentially across your sharding even to like make space for it and stuff. But I don't do that. I just there's S3 or DigitalOcean spaces or something like that. It's just, or the hard drive. It's like, but it's possible, yes.
Sorry for all the questions. Resume, and if we have time at the end, we'll get back to some of them.
Yeah, sounds good. So this data, like I said, this data is quite large, and it takes like 10 to 15 minutes to generate. So I don't want to do that live. That's why I dropped in the pieces that match it directly. So what I want to do now is go work with this, assuming we had written all of those classes that you just saw there, right? So we've written these. We want to go work with them. Look at this. This is from that, import this. I don't know. Anyway, it seems like it's happy now. So what we want to do is we want to go over here and we want to write our stuff. And let me put this back to our real database, not our little one. And I don't want to do my ORM stuff there. I want to create a different set of, now this is simple, so there's only be one, but a set of services that let me sort of encapsulate the data access for working with our data. So I'm going to call these services, not as in like web services, but as in provided to the rest of our app. I'll create a thing called package service, And in here, we're going to have some functions like, for example, let's do something really, really simple. Let's go down here to this print header thing. And it wants to do, actually, I did put that in a class. Let's just do it like this. I'll put it in the class, it's fine. So I'll put a class here and we'll have a class method. Actually, we'll just let it do this for us. So what we're going to do is we're going to import package service, like so. And then we want a function called how many packages are there, how many releases are there, how many users, how many downloads. So let's just write these really simple ones first. And notice that it's like got a red, not a red, like a yellow background, because it knows, PyCharm knows that package service doesn't have this. So I can hit Alt-Enter and it'll write this for me. Okay, so let's go and write this function. So here's what we're going to do. When we return, we need to go to package. This is how you query the database. This is our object that we wrote, and we can import it at the top. And we're going to go to this thing called objects. And normally you would put like, I want the name to be equal to whatever, right? But we don't care about the name. We just want to do a dot count on it. Okay. And we're going to do a release. So we're just going to crank these out. They're going to look super similar, but it's going to be release history, I think. Yes. And we want another one that is for users. So we're just going to bust these out really quick. This is going to be user. It'll have the nice side effect of importing everything that we need. And we have one more, which is going to be download. Download count. That's going to be download. Import that. And there's a little squiggly right here because pip8 says there's a new line. So hit Command-Alt-L, and then that'll put it at the end. So let's run this really quick. Did I uncomment that? Yes. So let's run this. And you can see our little PyPA data explorer is out. We have 50,000 packages, 250,000 releases mapped to those. We have 20,000 users and 500,000 downloads. And what we want to do to show all this off is to exit, because we got to write some more stuff. So this is really quick and easy, but now let's go actually write the interesting thing. So if I say query packages, it's going to give me a name, say, hey, what one do you want to search for? So let's go over here to this package service, and I'll leave that note there for a minute. So I'll have to say package is this, and we'll say package service dot find package by name, let's say, and we'll pass in the name. Again, we can write this here. It's going to take this. So we're going to come down here. We're going to do a query just like before. We'll say package equals like this. And we'll say objects. And now it gets interesting. So we'll say name equals name like that. And then we'll say dot first because we're looking for one, right? We could put a uniqueness constraint on this to make sure there's only one, but I guess I didn't do that. And then we can just return that package. Okay, so that's working pretty well. And we might want to do a little test because they could type in anything and it might not exist. We'll say if not package. If it didn't exist, it'll just come back as none. So we'll say print, let's go crazy and do some F strings. Say, sorry, no package with name. And we'll just sort of inline this here, name like that. And then we'll bail. The other thing we want to do is get release. We need the latest, I'll call it latest actually, to make it more clear. Get the latest release, because remember the package just has like the name of the maintainers. It's really the releases, each version that is most interesting. So this is a slightly more interesting query. So we'll say package service latest release, and we'll just give the package here. All right, so we'll go and use PyCharm to write that. And we might want to get a little bit of help here. So if I type package dot, oh my gosh, well done, PyCharm. Well, let's do this though. Let's go over here and actually give it a type hint and say package as well. And say this returns an optional release history, like that.
Type hints, woo-hoo!
Woo! Right, okay, so this comes from typing.optional. It means it could be none or it could be a thing. So down here we'll say release equals release history dot objects. And the way we want the package, there's no help here. This equals package dot ID. Okay. And then this is going to give us a collection, a query set. So we'll say first, oh, sorry, take that back. That's not quite right. Let's do this and this, but we have one more thing we need to do first here. We need to say .order by. What you do in this part, you put a string here. So we'll say negative created. Now remember, when I put this here, oh, it's ordered by version number. So this is perfect. So we're going to say, give me the most recent one. You could sort by version number, but I randomly generated it in the database, and so it's not going to have the effect you're hoping for. All right, so we got this all good, right? We're going to go find all the ones that match, order it by the created, the reverse, show me the newest one first, and then just get that. And notice PyCharm is saying, we expected you to actually return, maybe a release history, maybe it's none. But once I say return release, then it's cool. It's like, all right, gotcha. You're doing what you said. Okay, so let's go back here. And let's do the same thing, if not latest. Now, why might there not be a latest when there's a package? Not every package has a release. Like 49,000 out of 50 of them have releases in the database, but there's a few that have no releases because of randomness. So we'll print, sorry, put an F string. Sorry, the package curly has no release. And this will be package.name. Okay. And of course, don't forget the return. Now, what we're doing is we're actually timing this, and then I'm going to show some details. Okay. And the reason I'm timing is I want you to see how long it takes to do these two queries and go talk to the database. And in fact, I think I need one more thing. I need maintainers. This is going to be probably the most interesting query we do in this whole thing. Maintainers equals package service dot find get whatever maintainers, and it'll be the package. All right. So how are we going to do this? Remember, this is like a foreign key relationship. In a regular database, this would be a join. So how does it look here? And this is going to be a list of user. Again, from typing. So what we're going to do, we have our package. Now this is going to be pretty cool. So we'll say users equals user.objects like this. Now what did we put to say, I would like to find, let's go look at package real quick. I would like to find all the users who have an ID that is contained in this subset here, okay? And also let me put this total downloads in here. We need to do this equals and dot. I think this is a long field, not a list, a long field. Okay. So we're going to go over here and we're going to get all the users, and we want to say something like their ID is kind of equal to package.maintainers, right? But this is a list of IDs. So what we really want is like an in query. I want to find all the users whose ID is in that maintainers. So you say dunder in, well, double underscore in. All right, and that gives us, it basically says, go find me the users where the ID is contained within this list of IDs. Now I want all of them, so I'll just return. Now this is a query set, and my philosophy is the database should be done executing here in this package service layer. It shouldn't bleed like ambient lazily evaluated operation. So I'm going to say, I'm going to turn this to a list. There's a slight performance hit to doing this, like, because maybe you're just going to iterate it, but it's actually like nice and clear. Like if there's going to be any errors accessing the database, it's going to be in these functions. So that'll find us the maintainers over here. Now there's a bunch of stuff I want to print out. So let me just grab that from my other example that I pre-prepared because I want to answer your questions and not print like formatting text. This. Okay. So let's here get our maintainers. This release I had called R instead of latest. I think, what did I call package? I called that. There's my maintainers. I'm going to put this down here. That can go. All right. think my little T1 is at the wrong place. So we're going to time how long it takes to do those database queries, and then I'm going to not time how long it takes to print them out. Remember, all of this stuff there's none of this like lazy evaluation stuff. This is all done here. So let's cross our fingers and run this and hope all that hangs together. So let's query the packages. Now, I just randomly named them package 1 through 50,000. So how about that one? Boom. Ooh, it worked. Amazing. So check this out. So we went down here and we said the package is this. This is its health status, right? This could easily be like on a relational database. This would be another table like a health, like a package health thing you do a join against, but it's embedded, so it's just right there. We got our current version. Here's its description. Again, that's random. The maintainers, there's only one now. Pick a different one. There's only a bunch of supported languages and 2 dependencies. The very first time that took forever, it took 11 milliseconds to do those 3 queries. Let's try it again. On a query, this time I want package 7777. Now it takes 6 milliseconds, right? It's a little bit more warmed up. Okay, so here we can see this one's also failing. I should have tended towards a more positive outlook. Anyway, this one has a bunch of maintainers. That's that in query that we did, which is pretty awesome. And then these are the embedded elements that came back. All right. So let's do one final thing that I think is interesting, and then I'll open it up to questions. So the last thing to do is to say, I want to go over here and grab this T1. Oop. Is I want to write a query that says, give me the most popular elements. Now, there's 2 things that are interesting, and it'll just take a moment to cover, then we'll open it up. So let's say we want top packages will be package service dot, or let's take your pick, package service dot popular packages. And let's say we're going to set the limit to be equal to 10, right? Because that's how many we're asking for. Now let's go write this. Well, excuse me, let's let PyCharm write this. Beautiful, thank you, PyCharm. It takes a limit. That limit is going to be an int, and this is going to return a list of package. Service, no, package. So down here, this is going to be great. We're going to write a query, and it's going to look a little like this one. So we're going to say packages equals package dot objects, and we don't care about which one. We just want to sort them. Say order by total downloads. Oops, I want that. No, I want the biggest ones first. And then I'll say, yeah, that's fine. If I could make this plural, that would be fine. And then I want to limit the results to the number that I passed in, right? So I don't want all of them. I just want that one. And let's make this more readable, like this, like this. Then again, this is a query object that when evaluated will hit the database and do its thing. So let's make it hit the database now. All right. So this is going to return those items here. And then let me also grab just the text of printing that out again, just for time's sake. There, like this. Okay, so that's going to let us print them out. We use this cool little F string. We'll do that in milliseconds. Let's run this again. Oh, I noticed there's a bunch of these running now. Let's do a single instance, like restart it if I haven't stopped it. So let's go down here and make these go away, because it has that infinite loop. Okay, so let's query the package one more time. Package 777. Great, 4 milliseconds. Now let's just ask about the download analytics. Boom, there they are. So these are the most popular packages. I know you recognize these names. I use this one all the time. So we've got those back in 2.9 milliseconds, and we've got all that information. So very, very sweet. Paul, I think that pretty much concludes our little demo. We can do the 2 things it says in the menu, and we can exit. So maybe open it up to questions. And then I'll do a quick, try to keep it pretty quick because of the timing, but really quick review of actually, let me review the concepts and then we'll do the questions, okay?
All right, that sounds good.
Yeah, just for time's sake. So let's look back at the concepts that we covered. we didn't talk a ton about designing the data. One of the really important, this is actually the hardest part, and it's a bit of a black art. There's not like third normal form, do that, and that's how you model your data. It's really kind of open-ended. So there's 5 or 6 questions you want to ask yourself. Is the embedded data, so in our example, like the dependencies, for example, wanted when you have a package 80% of the time? Like most of the time you get a package, do you care about asking questions about its dependencies? Then embed it. If not, then don't. Similarly, how often do you want the embedded data without the containing document? So do you only want, there's not a great example here, but in my course where I had the chapters and I had the lectures are embedded, like do I just want the lecture without the chapter and other lectures? You can't easily get that when you embed it. You can work with it, but you can't pull it back without making the database do the work. So like this tells you how sort of broken apart and related your data is versus nested. Paul mentioned that the documents can only be 16 megabytes. So if you're going to put like analytics like page views in a page record and it's going to grow infinitely, that's a problem. It's a problem, and they make it a limit to save you, because if you're going to do one query and it's going to read 16 megabytes off the disk over the network and deserialize it, that's a crazy amount of work. So they have sort of limits on the size. That's why the bound should be small. And then how varied are your queries? How many different angles are you asking for this data? The more the angles, the more separated the data is, the more focused it is, the more it's clear, like, well, these things are always needed, so let's just embed them versus separate them. And then this concept of a sort of inner application database for like a lot of microservices, or do you have like one massive shared database? All right, so these are kind of the rules of thumb that you use to decide how to model your documents. There's a great book called something like MongoDB Applied Design Patterns by Rick Copeland. The title's not quite right, but the author is. And he has some really great examples of very non-intuitive ways of doing that. So registering connections, you saw that, super easy, just register connection, and then you refer to it. Creating documents, like a lot of the ORMs, just define the columns here. Except for it gets interesting because you can have embedded documents. This would do an animation that's cool, but I can't because it'll mess up my resolution for the recording, I think. So you can have these embedded document lists and put them in here, and that's really cool. So this is like one of the powers of modeling. Like in this case, this is like a little fake Airbnb thing for snakes. So you can book that cage and just store them this way. Okay. You can do a query, and you can do either objects and put the stuff in there. You can do .filter and then append many filters. You can only do one objects. So it depends, like if you have an if case to add on another item, you'd use filter, and you just say this and call it first. Right, very nice. You can do queries deep down into the objects. We didn't see this, but like the bookings contains a list of things which contains a guest snake ID. And then when we want to ask the question of, show me all the records where that ID across that list is contained within this other set that I have here. And so you just use the double underscores to go from the higher level to the next level down, to the next level down, and then apply the in operator on it. So it's really rich what you can do here. All right, so that's pretty much it. If you guys want to check out more of this stuff and you don't want it rushed through, right, I've got a 2.5-hour free course, and I've got a 7-hour, like super detailed with deployments and performance and all kinds of stuff, other course. Feel free to check those out. Other than that, Paul, I think I'll just open it up to questions.
All right, cool. Be careful what you ask for. We got a lot of questions.
Well, right, here I only have like probably 10 minutes, maybe 12 minutes to answer questions that I got to run. So we got to time box it.
Okay, then let's go through them fast. Hand-wavy consultant talk about scaling. Is it better to have large files with lots of data or small files with data spread amongst them? You talked a little bit about it a second ago on analytics.
Yeah, it depends on what you're trying to do. If you want all the data, it's probably better to have fewer large documents, because that means you're not doing like second queries. Like for example, over here in my little service thing, actually, well, I had to do one query to which one? This one. One query to get the package, and then one query to get the maintainers. Like if you're always one of the maintainers, in this case, it doesn't make sense, but maybe that gets embedded. You know, it's a real tough trade-off to make, but it can handle lots of.
Your course says the 80% rule, right?
Yeah, I would say. And what I would also really emphasize, like, it's critical that you put these indexes here. Indexes are more important in document databases than they are in regular databases. Why?
Interesting. All right, here's an easy one. Can you set up a local server?
Yeah, that's what this is.
All right, cool.
So
can we handle?
You just run it with a config file. You just say MongoD -- config, and you pass a config file, and that's what we've been working with here.
All right. On the null data one, we can't read null data through the Mongo shell. That's something related to the Python mapping. Is that true?
The problem is that if you use the the Mongo engine, the mapping doesn't push it through as null in JavaScript and JSON. It just doesn't put it there, and so it depends, right? So there's two ways. Like, if programming languages was null in JavaScript, none in Python, this query would still work and it would still find only ones like this. But if I wanted to say this, it gets tricky because you have to say it doesn't exist. Like, null and not existing, these are not the same. So you've got to write like a does not exist query. You totally can do it, but it's slightly annoying in that regard. But it saves you space, so and speed. So it's a trade-off.
Okay, if your data is very simple and can go in one relational table, would you prefer MySQL over Mongo or Mongo over MySQL?
Mongo, period.
Yeah.
No. The reason is migrations.
Yep.
If I want to add something, to this, yet another thing equals Mongo engine dot int field, like say.
Right.
This totally works. This fails if there's SQL alchemy pointing at a relational table. I got to go do a migration script, and I've got to, it's just the evolution of your data is simpler in the document database. That's why I would choose it. There's not a huge other reason.
Okay. Does Mongo engine provide a connection pool or even something with thread local?
Yes, it has a connection pool. It does connection pooling, and it talks to replica sets, and if there's a failover, it'll auto failover to the other replica, all that kind of stuff. Yeah.
All right. Yuri already does this, but wants another opinion. How do you store and process regular expressions?
There is a... are you storing the regular expressions themselves, or are you trying to use regular expressions as part of a query? I think just regular expressions are stored as regular text, I would guess. But there's like a way to do like a caret type of thing, or I don't remember the syntax exactly.
All right.
But you can actually do regular expression queries in the shell and things like that. But indexes only work under certain circumstances, like if the regular expression starts to the beginning of the string or something like this.
What are the most common performance killer mistakes that we should avoid?
Common performance, number one, no indexes, right? You can always ask, is there an index? If you say, explain, tell me what you're doing on the end of any query. And if you see IDX, good. If you see table scan, bad. So number one is missing index. And the reason is with these nested objects, those would normally be like foreign key relationships against primary keys. When they're nested, they're no longer automatically given at least one key. So there's just fewer indexes by default. So you got to put them back, basically. The other one is, I'm going to say bad document design, or like a document design mismatch. And I don't think it's really hard to say what that means. It could be over embedding, it could be under embedding, but just not aligning your document design with your most important common queries.
Yeah, if your common query takes 800 requests to fulfill its function, you didn't embed it correctly.
Yeah, exactly. And so, just really quickly,
I was answering questions and I missed this one. What was the shortcut to have PyCharm auto write the shell of a function? I didn't see what function you did the magic
if you say like this package service dot other thing.
Okay.
And it's basically any of the code intention. Anytime you see a light bulb, regardless of its functions, import, whatever, it's Alt Enter.
Yep.
And then you just choose from the list.
Yep.
That's what I did.
Alt Enter is your magic janitor. How do you feel about Couchbase compared to Mongo? Don't spend too much time on this one.
I honestly haven't spent a lot of time on it.
Okay.
But it really comes back to this picture. There's many more
Right.
ways to access MongoDB, many more libraries, many more ORMs or ODMs. It's been taken through the beating a lot. I mean, it's more used. I'm going to say more mature. I mean, there's a team of like at least 100 people that work full-time on MongoDB for like since 2010. It's like an insane amount. It's really an interesting story around open source business success. But
Yeah, there was an article by, was it RethinkDB that folded last year?
Yes, it was, sadly.
And sadly, it was a better architecture, better design, and it lost. And the founder wrote this long article about why Mongo beat it.
Yeah, it's not always technical. Well, I mean, business of software is not just software, sadly. But along those lines, MongoDB, I believe, is bringing in new features around real time. Like you subscribe to changes on a query and it'll push those to you, kind of like to fill the gap that RethinkDB fell out of.
All right, last two. Can you re-mention the book and author for data modeling?
Sure. Let's say Rick Copeland. I'll even do this. This will give you 2 resources.
All right, not 1, but 2.
So on Talk Python 109, I interviewed him and we talked all about this stuff. And then I mentioned it. So then his book is MongoDB Applied Design Patterns. And he has the O'Reilly. Oops, it has the O'Reilly and the Amazon link here. And I'm already in front of the show.
All right,
so talkpython.fm/109 is the link you need.
All right, last one. How to explain aggregations in the shell? Google it.
So what is aggregation really quickly, right? Can we just show me what this is, please?
Feel free to just give a quick explanation.
So aggregation, let me look. I just want to show people what it looks like. Mm-hmm. It looks really, really different. So it's a competing idea to MapReduce, but it's richer, right? And so this is the kind of stuff that you would write. You would say, go to your collection and aggregate and match. This is like sort of the where clause where the status is this, and then create like a one-to-many mapping by ID of customer, and then do a total where you sum up all their items. And the problem is you don't have a lot of operators like sum and group by and stuff like that in document databases. So this aggregation framework lets you do that and still execute them, say like within a cluster, a database cluster, and then give you back the answers.
All right. Believe it or not, we're at the end of the questions.
Good, because we're also at the end of time.
All right, let's do the wrap up.
All right, sounds good.
All right, we're going to switch over to my screen. All right, thanks, Michael, for taking the time to talk with us about MongoDB and Python applications. As a reminder to everybody, lots and lots and lots of material. Hey, tell us real quick about the All Products Bundle pack for people who need help on everything.
Sure, so I have a bunch of courses on Python, web apps, PyCharm, MongoDB over at training.talkpython.fm, and I set up what is kind of a subscription where you can buy like all the courses that we've got there and all the ones that are coming. There'll probably be like 15 to 20 courses coming this year, just all under one banner. But I don't like subscriptions. I don't like making people pay for stuff they've always bought and kind of holding their reference material as ransom. So what it really is, you own everything you pay for, and just if you want the new ones next year, you'd have to kind of renew. But it's kind of a buy it once, own it forever thing. So that's what I got going over there.
Right. It's kind of like our subscription model. You have a perpetual right to use for the version you bought, the version you got when you started.
Yeah, I hadn't thought about it, but it's exactly like that. Yes.
Yeah. All right. So if any of you have any questions later, please don't hesitate to reach out to us by email or social media. Tweet at us. We will probably see it. Go and fill out a comment on the blog post for the recording for this. We will answer. If you'd like to get more information on PyCharm, please go to our website at jetbrains.com/PyCharm. We'd love your feedback on this webinar. seriously, you're going to get an email and it's going to have something about filling in a form. Fill in the form. We read it. We learn from it. We pass information on to Michael. But otherwise, feel free to contact us on Twitter. The recording will be made available on our YouTube channel and announced on Twitter and the blog. It will be soon, by some definition of soon, either tomorrow, next day, probably this week. If you haven't already, please check out our PyCharm blog. We're really proud of it. We put a lot of work into it. On our blog, you can find up-to-date PyCharm news about releases and events, in addition to educational resources. So, for example, the recording of this webinar will be published first on the blog. We'll also provide some additional links and information from the presentation on the blog when Michael pushes the stuff to the repo.
Yep,
So
I'll do that shortly.
That's all from us today. Thank you very much for joining us, and hope you all have a nice day.
Thanks, everyone. Bye.